If you're in the cloud-native world, you already know Kubernetes is the king. But what happens when you need to manage the king itself? Well, today we're going to dive into Cluster API, which is this really cool project that uses Kubernetes to manage, you guessed it, more Kubernetes. Let's get right into it. So let's just be real for a second. If you've ever worked with Kubernetes, you know it's incredibly powerful. But you've probably also asked yourself this exact question. I mean, getting one cluster up and running, that's one thing. But managing a whole fleet of them, day in and day out, across different clouds, that's a whole other ballgame. And that's where the real headaches start. You know, to really get why the solution we're talking about is so elegant, we first have to understand the sheer scale of the problem. This wasn't just some small annoyance. For a lot of people, it was a massive roadblock to using Kubernetes seriously. To try and solve that initial setup problem, the community basically created a whirlwind of different tools. How many? Over 100. Yeah, you heard that right. More than 100 different Kubernetes distributions and installers. And every single one had its own way of doing things, its own opinions. It was basically the Wild West of bootstrapping a cluster. All that fragmentation left the platform operators, the actual people running all this stuff in production, with some really serious unanswered questions. Like, how are you supposed to get consistency when you're provisioning machines on AWS, and then on vSphere, and then on bare metal? How do you automate something like an upgrade without any kind of common standard? And the big one, how do you do any of this for not just one cluster, but for dozens or maybe even hundreds of them? So the community saw all this chaos and decided to take a really critical first step. They said, okay, we need to build a foundational tool, something to bring just a little bit of order to that initial cluster setup. And that tool was KubeADM. Its mission was absolutely laser-focused. Create one single best practices way to bootstrap a Kubernetes cluster. It wasn't meant to be the entire solution, but it was a standardized, reliable building block that other tools could then use, and in that mission, it was a huge success. But here's the catch. KubeADM was fantastic for day one, getting a cluster born. It did pretty much nothing for day 2 and beyond. Things like keeping that cluster healthy, upgrading it, scaling it out, or even deleting it. All those core long-term management problems, they were all still there. And this brings us to the core breakthrough. It came from the Kubernetes Special Interest Group for Cluster Lifecycle. They asked a totally revolutionary question. What if the best way to manage Kubernetes was to use Kubernetes itself? And that incredible idea became Cluster API, or CAPI as you'll often hear it called. Its mission is spelled out right here, to give us a declarative Kubernetes-style API to automate the entire lifecycle. And I want you to really focus on those keywords: declarative, simplify, and operate. This is the truly brilliant part. Instead of inventing some brand new tool with its own language, they just leaned into the very patterns that make Kubernetes so powerful for managing our applications in the first place. The core idea was to use those same familiar declarative APIs to manage the clusters themselves. I mean, just think about that for a second. You define your entire cluster, its machines, its network, everything, in a YAML file just like you would for a pod or deployment. You run kubectl apply, and boom, Cluster API makes it a reality. The result is it's transformative. You're no longer scripting the steps to get there, you're just defining the desired state. And this gives you deployments that are perfectly consistent every single time. It doesn't matter if you're on AWS, Azure, vSphere, or bare metal. And because it's all API-driven, it is built for automation from the ground up. Okay. So with any big, powerful project like this, it's just as important to understand what it doesn't do as what it does do. So let's get really clear on the precise scope of Cluster API. The goals are super clear and focused. First, manage the entire lifecycle, from creation all the way to destruction. Second, it has to work anywhere, across any cloud or on-prem environment. Third, it's got to be extensible. So it defines common operations, but it lets different providers like AWS or Azure implement them. And critically, the goal is to work with the existing ecosystem, not just replace it wholesale. This slide is perfect for drawing that line in the sand. So CAPI will manage your cluster's lifecycle, but it's not going to go and manage some random S3 bucket for you. It wants to integrate with awesome tools like COPS, but it's not going to force them to adopt it. Here's a really important one. It can only manage clusters that it provisioned in the first place. And finally, it doesn't try to do something crazy like stretch a single cluster across multiple clouds. That's a totally different problem space. Of course, technology this impactful doesn't just appear out of thin air. It's the product of a really vibrant open source community, and that community is always looking for new people to join in. And I just love this quote from the official documentation because it really says it all. This isn't some corporate products being handed down from on high. It's a community effort for the community. The project's success is totally tied to the people who show up and contribute. So, if this explainer has got you excited and you're thinking, hey, I want to be a part of this, here are some really concrete ways you can get involved. You can hop into the conversation on the Kubernetes Slack in the hashtag Cluster API channel. You can subscribe to the SIG Cluster Lifecycle mailing list, or you could even just sit in on their weekly public meetings. And hey, if you want to contribute code, the issue tracker is a fantastic place to start. So there you have it. That's Cluster API. It's this powerful abstraction that handles all that complex, tedious work of managing infrastructure for you. Which really leaves us with one final and, I think, really important question. If creating, scaling, and upgrading your Kubernetes clusters becomes as simple as applying a YAML file, what amazing things could you build instead?